Okay, thanks a lot for joining our session 4 for our design pattern course. Quick reminder of author of our course. We have me, Irina Kamalova, who right now VP lead software engineer at JP Morgan Chase, and ex-Revolut and ex-Yandex, which is Russian Google. And I've built and support many real-time systems. Last time at Revolut, it was systems that support 45 million clients. Overall, through all these years, I got a lot of touching Java and other object-oriented programming languages and functional languages, so Scala as well, and Python. So I have a lot of ideas why those patterns emerged and how they right now implemented in distributed systems. And I'm here to give my experience for you. We also have Sonali. She will join us later. And she has 14 plus years of experience in e-commerce solutions. So that's quite huge experience that she also bring in our course to help to build these presentations and do our lectures more interesting. And one more person who helped us is Leslie. And she started to learn these patterns just a little bit in advance than you, our attendee and audience started. So she helped us to make this as much democratized and simple and clear as possible. And bring her ideas like, if this pattern was clear from the book, or this one should be explained more. So we hope that this course really help all of you to build very robust fundamentals knowledge around patterns, how to do them, how to apply them. So yes, and let's start with refreshing. Last session, we spoke a lot about creational patterns, which is 5 of them. And I would question, first of all, you, anyone who would like, how would you explain when do we need creational patterns? Ragnar?
I think we need creational patterns when we need to create objects or something repetitively in the same way.
Yes, it's when we need to create object repeated way. Well, every time when we create new program, we can say that we repeat ourselves, right? So we create program from beginning again and again every time when we create new one. So that's kind of weird to say, but I wouldn't think that's when we should repeat ourselves inside the same program. I would think more like just the beginning of the program, like when we want to create something. And who would like to name those patterns? Yes, Irina?
Oh, sorry, I thought I'm going to answer the question.
But please go ahead.
Yeah. So when we want a scalable way, I think the scalability here is the key, because in general, we want to create kind of the same object, but not necessarily the same, right? So we can create a factory and then we can tweak it depending on like additional features that we want from it, so that we don't repeat ourselves many times.
Yes, that's absolutely fair point. Yeah, I agree. So I would think about creational patterns as something that we use in the beginning of creating our application. And that's exactly because we want to build something scalable. So we want every area you change of object that's created, or the way how we are creating them, to be flexible, to be scalable. So that's why we do not use just simple new as we do in Java and other programs, but we use the idea and approach when we think how exactly to create. And for Python as well, like we think about, okay, that is object that I will use across several programs, that's across several models. So I put it in separate model. So that's becoming my global object. And I can reuse it a lot without worrying that I can duplicate this object, for example. So that's about thinking how we structure our program. And very good note from Dennis, applying dry principle, do not repeat yourselves. Yeah, you, is it good?
Yeah. I was wondering why you say it's only when we are starting the application that we need these creation of patterns. I thought this was used for any moment where we want to create a specific type of object. We would use these patterns, not just when we are starting the application.
It's also correct to say I'm telling about starting an application because we should start somewhere, and this is first ever point of our program to start is about creating new objects. Yeah, so that's why I'm saying about starting, but that's correct to say then application is running in real time, and we always continue to create new objects, modify existing objects through builder and prototype to copy them, which also give us a sense like basically we create objects on the whole life cycle of our program. And for this, for any creation of our objects, we can use these patterns. Yeah, thank you for correcting me. Irina?
Yeah, I was thinking of only at the beginning, meaning I thought that you meant at the beginning of the development, so that we don't have to, like when we're developing something, some application, we would rather, it would be nicer to start with abstractions, to start incorporating the abstractions into our code from the beginning, instead of doing like repeating yourself over and over and over and then doing the huge refactoring. I think about it this way.
Yeah, here I would say any creational pattern, we should think about it in advance before developing the program. But we can say that creational one, mostly we use them when we think about entry points where the program is begin, like what will be the first ever objects that's going to be created and how we will create them. So in case of Java, we will think, oh, maybe we will build factory for repositories, abstract factory, or maybe we will use some framework that's like basically modern frameworks like Spring Boot. They have this annotation that's already abstracts from us the need of creating fabrics, but we think still about structure like there is factories. Yeah, so we think about packages in this case, like what packages we use to put our several bunch of objects that should be created on some level. And in case of Python, I would think how we would structure it model by model, like should we create model like a folder and then put there all these models that's responsible for repositories, for example, for connection to database, like how we structure it with models as well. So that's we can think like, okay, where is a factory, abstract factory, bunch of models for repositories? Where is this one for resources? Where is this one for what else services that we're going to use to transform data in Python? They still, even like we don't use patterns in Python in the same way as we use it in Java or C# or C++. But we still think like, how do we structure our program model by model? So we have something like, okay, here is one factory, here is another factory, and it's easy for us to navigate as soon as our program evaluates. We still have this very structured approach where we think, okay, this is placed in this model, this is placed in another model, and for us to easy navigate, and also easy to write tests. We think like, okay, right now I put the test only for this model, bigger level, but also only for this function inside this. And we have the same at the end structures way for building our test environment as well, and our tests for our models. And I would read the comment from Dennis. The idea to start the application with the idea to design. Keep in mind how to discover the most applicable patterns to your code and apply it exactly. Yeah, thanks a lot for this note. Okay, let's go next. Today, in our first session, we're starting to discuss common pattern. And if we go to the end of our book that we read before this, we will see that at the end they also show us which one pattern is which one group. We didn't talk about it in advance. We started to talk about only right now. And that's because, for example, for creation of patterns, there are only 5, and we covered them. So we are happy to continue with a lot of knowledge about them. And now we think, okay, what about others, where they are? And today we are talking about common pattern. It's in group of behavioral pattern. And we already know some patterns from this group. So we started with strategy. We started with phase 1 strategy, and we also already looked at observer. And today we're going to look at common. So refreshing, like, okay, strategy is also about behavior. Observer is also about behavior. And if you saw, like, last sessions we discussed how system design can behave based on those patterns, while for creational patterns we couldn't say how it could be applied because it's just for creating the program, the one single microservice. While here we can say, okay, that's how objects interact with each other, but then we can also move to system design and say how we can think about bigger system when we separated objects to microservices. And now one object is one microservice and another object is another microservice. And now we have framework to navigate through patterns and think about system design as interactions between microservices. So if I explain by myself in my words, behavioral is we create a pattern for some behavior from scratch. Yeah, and that's what's important. We think how to behave and we do it from scratch and we think like what is a pattern there. Yeah, so that's about behavioral. So let's talk about command. We have very interesting example in this book as a request from stakeholders. They basically wanted us to implement some tools that will allow us to do remote control against our house and build smart house, for example, smart home. So we see also everything that stakeholders that's responsible for those devices provided us as classes, and we think how to put it in our system control. Yeah. And we think, okay, we need some pattern, and we definitely have on and off everywhere. So let's say that on and off could be responsible for one interface, which looks like command. Yeah. So we come into the idea of the command pattern, which encapsulates the request as an object and letting you parameterize other objects with different requests. And also, it supports undoable operations. Yeah, so I would think that undoable is important part of this pattern because without undo, it could be just different strategies, right? Without having these switchers precisely, we can think like, oh, it's just different behavior. But what is an important thing and detail that make it another pattern, not just strategy, it's these undoable operations, we should think how not only on and off set TD set duty, etc. Or like if we talk about this example from the book, not only on off one device and another device, then another device, but also how to come back, roll back to the state that we had in the beginning. Like, what if we don't want all these changes? So that's basically what we're trying to think in advance. Yeah. So if you remember the application in chapter 2, and why I put it here, because I like that they're also going back and trying to challenge you, like, okay, we had something before, and couldn't we apply the same pattern here? Yeah, which is in our case observer, and why observer couldn't be think about comment as well, how to think about comments. And basically you can say that it's the same pattern, and which is I liked about patterns and thinking more about them. They're not limited and they're not isolated from each other. Yeah, we can think how they can combine each other. In case of observer, we think that we have buttons, and buttons could perform some action, and we have listeners to those actions. Yeah, so basically, in this example, in the book, we implement observer pattern, but also we know that our observer could be combined with comments. Yeah, we're still on the presentation screen. And let's go to class diagram. Yeah. So basically, we have different actors, which is one invoker who will do all commands. Yeah, the command, again, as I said, important idea around this command pattern, that you have undo command. You use this pattern when you think that you have something in your system that you need rolled back at some point. And basically that's it. You implement commands through execute and undo, and you have a receiver that gets these actions as well. And a real life example, again, that I already mentioned in the beginning. If you build some bot, for example, Slack bot, again, it could be Telegram bot. That's my personal experience of building this. You basically have commands there. It's not necessarily something you can undo, like cancel the execution of this command. However, just knowing that there is some pattern of it can quickly give you an idea. Actually, I don't want to have one class that do all my commands. I want to separate them. I will introduce an interface that will say command and execute. Yes, a simple one, even without undo operation. But you think like, okay, that's commands. That definitely could follow the pattern. What it will give you, for example, in Java, you build the package commands, you put interface command, and you have several classes that's implemented. In Python, you build model command. Under this, you build all models that have start command model, help command model, and you have abstract class for command. And again, basically, even if you don't use the concept of undo, of canceling command, you still can think like, okay, that's will be my command pattern. Yeah, like it still gives you the language how to communicate with another developer and say, you know, that's command pattern, so we will use command interface, but we wouldn't use undo, for example. Yeah, because, for example, for remind, for help to start, you don't really need to cancel those operations. Or Hangout, like you start meeting, you don't need to cancel this. Even without using the original concept where we say it's important also to think about commands that you can cancel. You still can say it's something like command pattern. So let's go to our guru. And what I will do, I will say design guru patterns command. So for those who joined us for the first time, we try to cover several resources here in this course. First resource is classic golf pattern book. Second one, the books that we read through. And third resource is this website. So you don't need to always have a book under the hood, but you can just go to this website and check what is a common pattern, for example, if you forgot. Yeah. So here we have the same examples. And I like their Java example more than the one in the book. Because in our book, they have only last command to undo, which doesn't make sense to me. We have device, we have button undo, we can do several commands, and I expect if I do undo button, I can undo several times, so I will roll back all my commands. However, in this book, they didn't implement this undo like you can undo several operations. Instead of it, if you check their code base, they undo only last operation. However, the power of our command pattern, that's when we create our invoker, the one who basically will do commands, we also build command history here. Yeah, a simple structure in Java to think about is stack. Stack is a structure when you put elements on each other, and when you get elements back, you know which one was the last that came. So it's like first come, first in, but last out. Yeah, so the one that was the first ever is against the queue, not the same as the queue, it will be the last one. So stack is a data structure that we can use to cancel commands. Whatever we put there, we cancel them one by one. And that's it. Yeah, so I liked this example a bit more. And also this example, a bit more real life example, because what exactly they suggest here, use commands for text editor. For me, it makes total sense. If you implement something like this, like text editor, you definitely need to have a story or a history of everything that's happened in this reductor. Yeah, because then I do Control plus Z. I want to cancel my operations, basically commands. So this is very good example to have in mindset, like, okay, where is the most applicable use case for commands? It's where I use command editor, like text editor. I do Control plus C as a command, Control plus V as a command, but also I can cancel my copy, paste, and cuts with Control plus Z. And here we happening. Yeah, Control and Z, yeah. Yeah, so that's very good example. And even they have, they give you some classes so you could play with it and do some demo. If you go to Python example here, we have a bit different one. And it's more like follow the general notations of methods. So it's a directly class invoker. It's a directly receiver, it's a directly simple command, complex command. So again, that's why it's important to check different examples. Some examples very good to memorize, like remote control switcher or editor. But sometimes examples are not that, for me, like it's not that memorizable, just simple command or complex command. It's for me easier to memorize particular live example to think about pattern. But the idea, that I said, is the same, different implementation. Abstract class, and then you implement this abstract class, while in Java you implement interface. Yeah, and another thing that they didn't do it here, but I would put them in different models. As we remember about creation of patterns, I would say I have several models that several commands, and everyone in its own Python file, which is complex /command.py, and they under the model commands. Yes, so we think about still how we could improve it even more with replica of our commands, which could be model, and we put them under our structure. The same like in Java, we will put them in separate package. Okay, so I hope that's very helpful examples. And let's continue with our slideshow. Again, here we've put how, again, for Python, we will put there. We will say, let's do commands for, again, paste and cut, but here example in Python for this. And we use screen command, and then screens that could paste, could cut, or could clear our clipboard. And of course, we may clear clipboard and we want to cancel it at some point as well. So for our commands, it's important to do undo. Again, it's the same idea as we saw in Java, but example in Python. As I promised, we have example in 2 languages. And then we can use them and run a small demo as well. You will have an access to this presentation after this session. Now, let's go to favorite topic. To be honest, in my experience, I've never used command pattern as patterns that I needed for low-level design of my applications. I didn't have such case. I used almost all of them, but not command. Still, I didn't have any business case when I needed to create state, change this one, and then cancel this state if something happened. Another pattern, if we will have time in this course, we will cover momenta, and that's say about having a state and cancel the state. Yep. But if I move on the upper level on system design, I have immediately example in my head where I may use it. And the first example that I would like to share with you is about Saga pattern. Is there anyone who can tell me, like, they heard about Saga pattern? You can raise your hand or share your thoughts. Yes, Narmin, would you like to share?
Yes, I believe that Saga pattern is used in the microservice architecture to manage distributed transactions. There are 2 ways basically to implement Saga, I believe: orchestration and choreography. Orchestration, basically, we have like the edge server, which basically coordinate the other microservices, gathers, all the information, and send back to this, the final result to the end client, basically. Choreography is basically the microservices between themselves, they coordinate each other. There is no one actually one actor. Basically, they are all in collaboration to manage this transaction.
Yeah, perfect answer. Thanks a lot.
You're welcome.
So, yeah, it's indeed about distributive transaction. And when I think about where in real life I need cancel my previous operation, the first idea that's coming to me, transaction, even not distributed one across several services, but even a seed transaction in databases. Yeah, you could change several tables, and then if last change failed, if it's happened in one transaction, the whole transaction will roll back, which is mean every step will be rolled back. Yeah, and we wouldn't need to implement a seed right now because basically we already have all frameworks in the place. Again, but in my experience, I didn't have to implement always undo for rollback for commit. Basically, that's something that even database will do for you when you say rollback, right? However, if you move again upper level, it's coming for distributed transaction, which say like, okay, let's go to the next slide. There's this example, planning meeting, book flights, book hotel, book transfer. So basically, you want to do all these actions all together. And if you couldn't do the last action, you realize that, okay, I need to plan meeting for another slot, so I need to cancel all previous steps. So here we started to talk about saga pattern, yeah, in microservices. That's another example I liked. I will put sources at the end. Unfortunately, the quality of picture wasn't that good to render, but I really like this example because that's something from real life. You're working on application. For example, Amazon app. Yeah. So you have order for someone who would like to buy from your stock. And you have several microservices that's responsible for this journey. First, it's a microservice that's responsible for orders. Second, the microservice that's checking if product indeed exists in stock. And third, the microservice that's responsible for processing payment. And the fourth one, the one that's responsible for delivery the order. So at least for very simplified thing, if we don't talk about Amazon, but we can talk about IKEA, a bit simpler because at least one stock for one location, not several shops, and every shop has its own stock. But anyway, even in this case, we do separate microservice that's responsible to check if product in stock, right? And if product is not in stock, we need to cancel the order. Then if financial operation couldn't succeed, we cancel reservation from the stock and we cancel the order. We couldn't cancel order without canceled reservation product from the stock, right? So we need to do several steps of cancellation. So that is our undo operation, yeah, undo. And delivery. If delivery fails and if package is lost, ideally we should refund money. And for example, delivery came back to us. Yeah, and just I couldn't. So we need to put product back to the store and cancel order. If it's good delivery, they just give us product back. There could be much more complicated cases when it's indeed lost, but we still need to refund money. So basically, we do not cancel order, but just put like it failed and money refunded. So it could be different ways. The main idea is that to make these microservices work together, we can use Saga pattern. And indeed, there are different approaches. In this picture, you see choreography, then they exchange messages, and there is no single coordinator for them. In orchestration is then you have single one who maintain all these processes as well, but here like they can do independently. So I see some comments. Temporal annual. Yeah, workflows that can be rolled back using the Saga platform. I didn't use temporal IO, but I will check. Thank you for note. And yes, good comment. It's part of event-driven type patterns. That's correct. And here in this course, we thinking about how these patterns that were introduced 30 years ago, there was no conception of microservices, but how today they behave on the higher level when we have microservices. So now we don't need those patterns that much because we don't have monoliths anymore. Some of them we don't need at all. We, instead of observer, use Kafka. And the same here for Saga, like instead of thinking how we do different commands and undo on the one single monolith, on the one single application, we now separate them to microservices, put to each team their microservice, but then we think, okay, how we should coordinate between each other. So we're growing up from object-oriented design patterns to microservices patterns, and we're trying to build this analogy, like how we can say, like right now it's command with undo operation, but on the higher level. So that's our Saga pattern. Again, it's easier to memorize what is undo, etc. Yes, but not sorry for keeping you in queue.
No, that's fine. I had a question related to that itself. Would that mean that the Saga pattern is more of command patterns that are kind of asynchronous?
Yeah, it's asynchronous indeed.
Because we're still doing both the things, isn't it? It's just it could be at different times.
For command, the same. You cancel command, but it's not like it could happen in different moment of time, right?
Yeah.
But what important about command, you use this pattern when you need to cancel some operations that's happened. And when we talk about distributed transaction, it's similar because we need to cancel previous events that's happened. We need to issue like process payment failed event, which will basically be your undo operation. So now instead of execute and undo, we have process payment succeed event and process payment failed event for choreography implementation. Yes, so two things. But they, like that's how we can build analogy between them. And we can say idea still presented, but now how we implement it, how we even call it with Saga, absolutely different here. But that's still idea exists. Idea exists. It's evolved into microservice big system design pattern.
Okay, thank you.
Okay, good. If we don't have any more questions on comment, we can go to adapter, but let me know. Okay, all good. Okay, so adapter. And let's first talk about structural patterns. So again, it's different to creational one and different to behavioral one. But we already looked at least at one, decorator, the one from these structural patterns. Yeah, so if I will try to explain in my own words what is structural patterns, it's when we don't change the behavior of original action, actor, entity, whatever, but we create a pattern for the structure that will allow us to add new behavior or change the behavior by adding a new layer. So when we talk about decorator pattern, we were talking like we have based behavior and we decorate it layer by layer. So at the end, we have chain of different behaviors, which is not the same as chain of responsibility, which is still decorator. However, that's our new structure, this original behavior. That's why it's not behavioral one, it's structural one. So that's also how we can navigate between them and the meaning of like which one is behavioral, which one is structural. Yeah, so we already looked at one. Today we look at the second one. It's give us even more context and idea why this one is structural one. So example that I like, and it was in this book, happily, it's about adapters. Basically, so for those who joined us in UK, you know very well that when you travel to Europe, you pick up a lot of adapters with you, like the one for USB chargers, the one for, I don't know, for Mac, because for Mac you have separate as well adapters, the one just for general socket. If you would like to go to Switzerland, apparently you need another adapters because they have 3 sockets as in UK, but that's 3 rounded sockets. Yeah, so I love this adapter example because that's about how we adapt different protocols for electricity. Yeah, thanks a lot for your actions. And actually, it's too early, but okay. If you want to consult with Raccoon, let's go to Raccoon. Adapter. Yeah, okay. So, oh, actually, they have similar examples that I put in Java. It's more real life example for me than the one that was in book, because in book they wanted to turn duck to turkeys, which is absolutely doesn't make sense, but also give you a good memory of this pattern. That's why I like this book, despite all this example is hilarious, but you memorize it because it's hilarious. Yeah, and again, adapters through sockets, that I like much more. And from real-time example, real life, I would say this one is indeed very painful for those who use Java, because sometimes you have a lot of stakeholders and you integrate with them this JSON, because JSON is new format. And then apparently you need one more system to onboard, and they have SOAP, and they use XML for their messages. And you don't want to re-implement the whole system for those beautiful providers for data. That's maybe like you need to cover a long tail users, so that's why you need to adapt your program to work with this provider. And for this, adapter is very good choice as a pattern. You don't change original behavior again. You just restructure the interface to adapt this one. And that's it. That's basically how we think about adapter patterns. Yeah. Let me check what I have, for example, for Java. Okay, round hole, round peg, square peg. And they want to do adapter from square to pack. Maybe it makes sense for Mars, but for real life, not sure if it's make a lot of sense. Let's check how they implement it in Python as well. So yeah, again, for Python, they used very, very abstract thing, just target and adapt, and that's it. Because specific request, and they adapt specific request to request, okay. Yeah, let's go to example with Java that I built for you. So I would say for this example where you use Java code and you need, again, JSON service to adapt to be also applicable for SOAP service. And what do you have there? You have to send a message in JSON format to be also applicable, adapted for SOAP service to send SOAP message, which will be XML format, and that's it. So here is our adapter. Basically, we say that we can mimic the interface of JSON service and convert our messages. So here in this example, I convert JSON to XML. Yeah, so it's very easy implementation, but of course in real life it will take you much more. Yeah, and that's it. One message, hello world, and another message will be adapted with XML tags. So that's a simple example to memorize and think about, like, okay, what is the case when I need adapter? Basically, I have data in one format, I need to adapt them into another format, and I don't need to change behavior in between. Yeah, so basically adapt something. If we think about Python, this is more a real life example again that we could figure out thanks to Leslie. We have media player and we have different audio formats, which is VLC. If you remember this, many years ago, I used it a lot. It could be MP4. And basically, we do not change the behavior, but we implement adapters. So what we can think about here, we use media player and play as an abstract method. So basically, we have play in one format and play in another format, and we adapt through adapt play method. Yeah. And you can also play, you will have an access to this presentation, and you can play all these examples to see how it works. Okay, before I move, so today we're quite quick. Let me know, what is your experience with adapters? For example, have you ever used adapters or something similar? Have you ever had to solve something that you think it was more like adapt one format of data to another format of data? Yes, Rachel?
So previously I worked in like solar forecasting, and I didn't actually build the software for the adapter pattern, but our backend, like our data engineer, had to collect a lot of different type of like meteorological data, and then that was coming from different sources, and his adapter that he built then formatted everything into the format that we used in our ML pipelines. So that was a very like clear adapter pattern that he implemented. So it's kind of like you have the adapter bit, which just takes any sort of data and knows it's coming from this source. So I do this, but the output was always the same for what we needed from it.
That's a very good example. And in such slice of thinking about it, I would even think that microservice itself could play a role as adapter in the system, right? So we can deploy a model like in Python, small one, but the whole idea of it will be accept request in one format and produce response to another service in another model. And that's it. It's already adapter, and that's how we can think about it again on system design level. Didn't put diagrams, but I want just to bring it as an idea. Pradna, you had raised your hand. Would you like to speak?
Yeah, I was going to type it, but anyway, I remember I was working on mainframes at that time, and MQ. I think it was IBM WebSphere MQ that was implemented to connect the front end to the back end, and they just don't match because their character format is totally different. The modern languages and mainframes. So I could build some kind of adapters to convert like just raw data into XML, and then convert MQ messages into some soap messages or something like that. I don't remember the exact example. But yeah, that was a very painful experience.
Yeah, yes. That's a very good example as well. And I would agree that sometimes the task like adapt something could be a very painful experience, especially if language is not designed to work in the easy way with this format. For example, if you would try to read spreadsheet list in Java, it's a very unbeautiful library that gives you this opportunity. While if you will try to read spreadsheets in Python, you will do it just with several rows and it will be so easy. So yeah, in this case, I started to think, can we use GraalVM first in our application so we can adapt both Java and Python at the same time? Yeah, Nermin.
Yeah, I also wanted to tell about my experience with adapter because I believe it also comforts to adapter pattern. So we had an application which was responsible for creating individual payment links for our clients, but after a few time, our stakeholders said that they want us to build batch links, like the client can send, can upload the Excel file, and in the Excel file they can want to build lots of links. So, but our system was intended to accept only individual payment links. So what I did, I basically, accepted the batch file, and I parsed all the lines and turned them into the individual payment links. So I believe it's also kind of the implementation of these patterns, because the client sent me the batch of this payment link request, but under the hood, I converted them into the individual using the middle layer application.
Yes, thanks a lot for sharing. And that's also a good example. And it's indeed, like, as Denis also mentioned, it's not changing exactly the data that's come, but change the format of those data and pass it next. So that's about adapting data. We use it quite oftenly in our application and our distributed system. Again, if we think about system design, and if we have microservices that have this exactly purpose to get data and change the format to adapt it to next microservice, we can say, oh, we're building like microservice, which is adapter. So I like how we can shift again our concepts to bigger level, to system design level, and how then we can build this language where we just understand each other. Because, oh, that's this pattern, I think so. Yeah, so for today's session, it was easy as in previous. But now we have these patterns into the place. Again, if you have any questions for everything that was here in our journey, let me know now before I go to the next slide. Okay. And I would like to raise this topic about combination of our patterns. Why I would like to raise it? Because we did all our creational patterns in last session. We already now familiar with few behavioral patterns and with at least 2 structural patterns. And let's think not only about every single pattern to be isolated and how it works, etc., but let's build here the thinking about combination of patterns, how we can build the program using these patterns, the whole programs, the whole microservices, the whole system. Let's start to use imagination for this. And where I would personally start when we build microservice or the system, we first think about behavior. Like if we build a system like IKEA digital system, like we accept orders, we should store them, we should find out what is in stock, etc. Then we should process payment, and then we should call the delivery. Yeah. So we think, okay, behavioral, it's about several microservices that should interact with each other. So the system behave as a one distributed transaction across services, and it's a saga pattern because we also may cancel different steps. Yeah, and that's where we start. We build system, we think about behavioral. Yeah, then we move to every microservice and we think about structure of this and models and then how we create them. Yeah, and then if we think about, for example, we think about process and payment statement service. And if you remember first ever session, we discussed strategy because there could be several ways to process payment. It could be PayPal payments, it could be Visa digital card payments, it could be MasterCard card payments. Yes, so 3 different strategies. And I think, okay, this is my strategies. Again, that's my behavior. And that's how system behave. I will use strategy pattern for this. I will have process payment as interface and different implementations like PayPal, like MasterCard, Visa as implementation. That's my strategy pattern. So first thing, behavior, and for process payment system for service, I would think about strategy pattern. Then I will think about structure. Yeah, like, okay, this payment coming, how I will structure the request. And is there any patterns again? Maybe I need authorization, maybe I need to log this request, etc. So that's coming as decorator. Yeah, so I know that I will use decorator. I know that maybe I will use frameworks, so I wouldn't implement it by myself, but I know that all my requests will be decorated. And that's decorator structural pattern. And then finally, I'll go and build application. That's process payment. Yeah, and I think like, okay, where I start, I have a fabrica of my repositories. For now, it will be 3 repositories. One responsible for PayPal service payments. I will store them in separate table. Another one for Visa MasterCard payments, and another one for MasterCard, and another one for Visa. Why? Because they have different format. So for me, it's easier just to separate them. And who will be responsible for these repositories? My fabric of repositories. It could be, again, my model in Python. It could be my package in Java. It could be built-in annotation repository, but that still will be in one package. So Fabric is still there, even I do not write it directly and do not create directly. I know that it will be singletons, singleton objects or global objects. So I guarantee that's only one. So that's coming down to creational patterns, because now I think, okay, how exactly I create this behavior? So I was thinking in advance, what is behavior? What is a structure? Now how I create this behavior. So my idea here is that when you build application, you basically can combine several patterns. And this is behavior. This is how I can restructure my behavior if I need to adapt some data. Maybe I need the series of adapters that will have my message to be useful and adapted for Visa, for PayPal, for MasterCard. That will be my adapters inside my application. My internal layer, my service layer model is the one, but then there is 3 adapters for my providers, for my integrations. And I think about how I create objects. So basically, I use all patterns. Convinced? Okay, good. Thanks for nodding. Oh, here I put another, well, as your mindset, I would engage you to think. I shared with you process payment, but think on your own after this session. As soon as finished, think like, what behavior, what structure, what creational patterns I will use to build stock patterns. Just put it as notes for yourself. Maybe you will conclude that maybe it will be all the same that I listed in process payment. Or maybe you'll come up with some another idea. Maybe you'll start to check what other patterns I could use, etc. So just have this mental exercise as soon as we finish session, and no later. And yeah, here I come with some ideas as well. Observers for orders, state of the product. We didn't touch state yet, so it will come later, but when you will brainstorm for yourself, it could be different patterns. Again, decorator for event, because here we don't have Saga for orchestration here, but we produce events. Maybe we need to decorate events to be verified, or maybe we don't. And again, creational abstract factory to build application of singletons. Build product, you remember that when we showed builder pattern, we showed product as an entity. Prototype to update product, like, is it 5 products or 1 product? Okay, yeah. Okay, here I almost finished with all resources that you can use to check. A lot of things you can also find, and always consult with Guru Patterns. And this presentation you will find just after the session in Slack. Now I'm happy to accept questions, and now I start recording. Let me do a moment for this. Where